Kia ora, Year 12. This is the first question I'm going to do from this year's Wellington College Integration Calculus exam. So this is question 2e, which is a differential equations question. The trickiest part in here, as is often the case, is working out what you're being asked to do. So we're told that we've got a DE, which is modelling the motion of a ball that has been thrown vertically upwards, and it's got an initial speed of u. What we have to do is to show that the ball reaches its maximum height when t is equal to this. So it's a show that question, no skipping any steps. And we've got to think about what maximum height means. So when we've got any kinematics problem, we're working with displacement, velocity, and acceleration. We get from displacement to velocity by differentiating, and the same from velocity to acceleration. So in this case, we can think of S of t, displacement, as height, and we're looking for the maximum height. So to find the maximum height, we want to have h dash of t equal 0, but that just means that velocity is equal to 0. So what the question's really asking is to find v of t and then solve that equation for 0 and solve it for t. So that's about it. So we're going to start doing our usual stuff to the DE. So step 1 is to solve the DE. Step 2 is to use the fact that V0 is equal to U. And then step 3 is to get an expression for V of t. And then step 4, I guess, is to solve V of t equals 0 and manipulate or rearrange, make t the subject. So that's what we're going to do now. If I get interrupted, it's because kids have turned up for Halloween. Hopefully that won't happen until I'm done. So there's dv by dt is negative g minus kv. The only trick we've got for DEs remains separating the variables. So here we're going to first of all take out a negative sign, and we get negative g plus kv. From there, we're going to take all of this and divide through by it. So we get 1 over g plus kv dv is equal to negative dt. We're going to integrate both sides as usual. On the left-hand side, you'll recognise that we're going to have something to do with log of g plus kv. But when I differentiate that using the chain rule, we'll get a term of k popping out, and we don't want that. So it's going to be 1 over k log g plus kv is equal to negative t plus c. That gives me this. Negative kt plus, now I'm going to write c dash. We can think of c dash as kc, but that's just an arbitrary constant, so I'll call it c dash. Or you could leave it as c, that's all right as well. At different points, you can choose to substitute in that V0 is equal to U. When we did the A-level paper, we did that quite early. I'm going to show you a slightly different approach today, but you can't really go wrong from here as long as you're substituting in well. I'm going to do the e to both sides thing now. So g plus kv is equal to e to the negative kt plus c dash. So we get g plus kv is equal to e to the negative kt times e to the c dash. And we're going to call e to the c dash big A, so it's just another constant of integration. So we've got g plus kv is equal to a e to the negative kt. Kv is equal to a e to the negative kt minus g. Now I think now is probably about time that I want to substitute in when t equals 0, v is not equal to v, it's equal to u. So that gives me ku is equal to a times e to the 0 minus g. Right, so ku equals a minus g. And as usual, we're trying to get an expression for a in terms of the real stuff in the equation, so ku plus g. Now I can take this and I'm going to substitute it back into here. Right, where am I up to? Let's just have a wee look. So g plus kv is equal to ku plus g. e to the negative kt. So we're making quite good progress now. We're going to get an expression now for, well, we don't even have to get an expression for velocity. I'm going to get an expression for kv. So I will go on here and get the expression for velocity to show you what we've got. Whoops, I've lost a minus g there. There we go. So I'm showing you this, but you actually don't have to do this. Right, so we could go all the way through here and then solve for when is velocity equal to 0. But I'm probably doing a bit of extra work by doing that, and you're going to be under a lot of time pressure. So let's just see what happens if I get to here, and now I just shove in v equals 0. So I'll have g plus 0 is equal to ku plus g e to the negative kt. Right, so solving for v of t equals 0. That's what we're doing here. G over ku plus g is equal to e to the negative kt. I'm going to take logs of both sides. Am I going to do that? No, I'm not going to do that yet. G over ku plus g is equal to 1 over e to the kt. So e to the kt cross multiplying gives me ku plus g over g. Now logging both sides, kt is equal to the log of ku plus g over g. T is equal to 1 over k times the log of this. Right, I think it's probably fine to leave it there, but we'll write it out exactly how it was in the question. So there we go, as required. All right, leave me comments if you're not sure about how I've done any of that. And as I said, there are a lot of different stopping points for where you can substitute in the constants. Thanks for watching. I'll probably be back with another integration question later on tonight.